Welcome back, everybody. My name is Dr. Don, and the topic today is going to be on castable mounting, sometimes known as cold mounting as well. I actually prefer the term castable mounting because cold mounting would imply that the resin actually doesn't heat up and get hot during the curing operation. However, the fact is that a resin can actually get hotter than a compression mounting if you're not careful with the ambient temperature and the amount of volume that you mix up. So to me, the more appropriate term is castable mounting. Vacuum impregnation. Why would it be useful? Let's discuss that a little bit more detail. Vacuum impregnation essentially allows us to fill in voids or gaps that occur in our sample. For example, here's a PCB board here, and after we cut it, we can see that there's some layers that are just open air. And if we want to grind this in order to protect that and not to deform that during the grinding and polishing operation, we actually want to fill that with a castable mounting resin. And the idea of how this works is essentially we'll pull a vacuum, we'll pour the resin onto the sample and while it's still under vacuum, and then we increase the pressure. And what this does is it pushes the resin basically into the void. Now, to even enhance that even more, you could actually cure it at a higher pressure using a pressure chamber as well. But for vacuum impregnation, it's very useful for filling in gaps, porosity, and other things where you want to have more structural edge retention before you go to the grinding and polishing operations. Paste Technologies offers a variety of castable mounting materials. The primary types that we offer include acrylics, epoxies, and polyesters. And within those categories, we actually offer specialized resins as well. So this is an example of an acrylic. An acrylic typically is a powder and a liquid, and you combine these together. And the advantage of using an acrylic is that they do cure very quickly. So if you have to turn around samples very quickly, acrylics are usually the best. The disadvantage of acrylics is that it also generates a lot of heat, so you'll get a little bit more shrinkage. So it's a little bit of a trade-off between speed versus the quality of the mount. Now, epoxies are great, and they come in a number of varieties as well. We offer a low viscosity, a standard curing epoxy, as well as a quick curing epoxy. Now, the quick curing epoxy you got to be a little bit careful with because it can generate a lot of heat and actually might cause some deformation to your sample. For vacuum impregnation, I would actually recommend the low viscosity because you're starting with a thinner liquid to begin with. Now, the polyesters are not used that much in the metallographic industry, but they do have a advantage of if you're trying to mount very large samples and if you want to have very clear samples. So if you're using it for displaying objects and parts, say you want to have a spark plug or something like that, and you cut it in half and you want to display that to your customers, what the features of that spark plug look like when it's opened or cut open, that would be the better resin. That would be a polyester resin. Castable mounting uses resins, and in the case of an acrylic, it's actually a resin and a powder, but it's still a liquid form. So in order to be able to mount your sample, we need to have some sort of holder. And we have a variety of different holders. What I'm showing here is actually a silicone rubber mold, and we have this in clear and in a blue color. And we also have it in a wide variety of different shapes. So it gives you a lot of flexibility in terms of what you can use for mounting your samples. We also have these two-piece molds which actually come apart so that you can actually remove your sample. Here's an example here. So this is an acrylic that's been mounted into it. Basically pull out the bottom piece there and it pushes up through the top. So it's tapered a little bit, but this is a way to have reusable molds. The rubber molds are also reusable, but they do have a tendency to break down a little bit faster than these plastic two-piece molds. Now for mounting, when you have oddball samples or samples like this PCB board, if you try to mount it on its side and you pour the resin in, it's probably going to tip over. So we do have a variety of different types of clips that are used to hold the samples in place and to orient them in the direction that you want. This is particularly just a nice, easy to use plastic clip. We have clips that have multiple slots so that you can actually mount different types of samples and multiple samples at one time. Another simple plastic clip. And we also have what we call spring clips. So this is basically stretches out so that you can put your sample in like this, and it holds it in place when you put it into your mounting cup. Let's mount a couple of samples. What I have here is our ultra-thin resin and hardener. Now, when we mix these together, we want to mix them in such a way that we don't create a lot of air bubbles. And so the best way to do it is just kind of a folding action. And you can, I'm not sure if you can see this or not, but it's kind of a cloudy liquid. So what you want to do is you want to make sure that the liquid turns from cloudy to clear. And then just for extra measure, go a few more seconds after that. This will make sure that you've got a homogeneous solution so that when it's curing, you don't get spots that are partially cured and some that aren't. So I think we're pretty good here. So the vacuum impregnation chamber here has this little sliding rod, so you can actually pull multiple samples or pour multiple samples. And let's go ahead and pour our resin in here. And there's a little, there, just so it doesn't fall. So now what we want to do is position this over the samples here, and just make sure that they're lined up properly here. Pull it out here. So we're pretty good there. So now what we want to do is we actually want to pull the vacuum. So at this point, we're actually ready to go ahead and pull the vacuum on the system. Now there is an O-ring on the lower chamber here that will help us have a little bit better seal. What I like to do is I actually like to use a little bit of Vaseline or petroleum jelly on there just to apply to the edge here, and that helps hold it down as well. Because you want to have a fairly good seal. And so we're all set there. The next step is to turn on the vacuum pump, and it'll get a little bit noisy. And then I'll go ahead and pour the resin under vacuum, and then we'll increase the pressure afterwards. So let me go ahead and do that. The one thing that we don't want to do too long is pull the vacuum for too long, because it actually starts to cause the resin to degas. It's actually known as Henry's law, which states that the solubility of a gas in a liquid is equal to the partial pressure above the liquid as well. So if you pull a vacuum, you actually will start degassing the resin. It's like opening a Coke bottle, and you get all the gas that comes out. So now that we've poured the resin, what we want to do is we want to slowly open up the valve. If we open up too fast, it actually will flood the chamber with air, and it actually cause it to splatter all over the inside of your chamber, so you don't want to do that. And now we just waiting for the resin to cure, and we have vacuum impregnated mounts. Let's take a look at the samples that we mounted up here. So this particular sample here, we see that we have a silicone rubber mold. Pull that out. See, actually it's a very nice looking mount, especially the ultra thin. It's a low temperature, low viscosity mounting compound, so it has low shrinkage. It also flowed very nicely into the, into the sample. It's also very clear. So, and then you see this is a flexible silicone rubber here. So the other one we have is our two-piece molds. And this, let me just pull that apart. So, and then you just press out your sample here. And here, this sample, you can see a little bit more detail. This was a capacitor a couple of capacitors that we had actually cut in half and then mounted. And in this case, it's a good example of why we'd want to use vacuum impregnation, because these wires in here in particular, you see the copper wires, wouldn't be unsupported. So if we actually went to a polishing operation, we might deform those wires when we were polishing it. But by using vacuum impregnation, just visually looking at it, it looks like we did a very good job of supporting the internal structure of this sample. So it should make it a lot easier from our analysis point of view. Again, the ultra thin, very nice, very, very clear. Castable mounting with the vacuum mounting chamber can be very useful for a number of applications. If you're mounting samples that have high porosity, or if you have even a large number of samples that you need to cast up at one time or mount at one time, castable mounting can achieve those goals. One of the issues with trying to do it with compression mounting is that you can only do one sample or two samples at a time. It also applies pressure. The nice thing about using castable mounting is that you're not putting a lot of pressure on the sample with a powder that may actually crack your sample. So in addition to filling porosity and voids that are in your sample, castable mounting can be very useful for a wide variety of materials.